representing about the introduction of oil and gas, which is the industry that we choose for the study case. So the first point is Malaysia's history with oil and gas began more than 100 years ago when Shell discovered the first oil in Sarawak in 1910. So today, Malaysia is the second largest oil producer in Southeast Asia and the world's third largest exporter of liquefied natural gas, which is LNG. At the end of 2020, the country held proved oil reserve of 2.7 billion barrels and natural gas deposit totaling 32.1 trillion cubic feet. Since its inception, Petronas has held exclusive ownership rights over all oil and natural gas exploration and production activities in the country. Among the prominent international oil production and companies currently operating at Malaysia are Shell, ExxonMobil and ConocoPhillips. So oil and gas are the valuable resources driving more than 50% of the world's energy today. So these two important resources are transported from one place to another by pipelines. So steel is the most commonly used material for pipelines transporting oil and gas, which is highly prone to corrosion. Next, in general, the development of oil and gas activities below the surface of the sea can be summarized into three stages, which are exploration, development and production. The firstly is exploration, where at this phase is the search for the location of the oil-bearing strata below sea level. And the next one is development, which is designing, construction, transportation, assembly and testing facilities for hydrocarbon extraction from below sea level. And the last one is production, which is digging, processing and transporting hydrocarbon from below sea surface to land for further processing. Next, the goals for the oil and gas, which is the first one is secure more control over the country's petroleum resources. Next, provide the commodity at affordable prices in the local market to boost the growth of capital and energy intensive activities. And the last one is to foster upstream and downstream linkages as well as the participation of local operators in the sector. So this is the types of corrosion in the oil and gas industry. The first one is sweet corrosion or carbon dioxide corrosion. Number 2 is hydrogen sulfide corrosion or sour corrosion. Number 3 is oxygen corrosion. The next one is crevice corrosion. And number 5 is erosion corrosion. Number 6 is microbial induced corrosion. And the last one is galvanic corrosion. So among all these types of corrosion in the oil and gas industry, I will more focusing on galvanic corrosion because galvanic corrosion is the main topic or the main corrosion that we choose for the study case. Next, this is a factor of corrosion in the oil and gas industry for galvanic corrosion, which is galvanic corrosion happens when two metallic material with different abilities, which is electrochemical potential, come into contact and are subjected to an electrolytic environment. In such a case, the metal with a lower or higher potential for corroding acts as an anode. The most noticeable sort of galvanic corrosion takes place when CRAs, which is stainless steel or nickel alloys, are coupled with carbon or low alloy steels in an anaerobic environment. If the nobler metal is sensitive, hydrogen embrittlement is also a possibility. Galvanic corrosion is facilitated by the presence of hydrogen sulfide and low temperatures. As we can see the figure in this slide, so this is the galvanic corrosion that occur in the pipeline in the oil and gas industry.
Okay, Assalamualaikum. Now I will explaining about the ultrasonic testing that is used to detect corrosion. Okay, ultrasonic testing is a type of testing that is rely on the generation and detection of mechanical wave or vibration within the sample being inspected. So ultrasonic testing is the one type of testing that are using wave to detect a defect or flaws in a material without destroying the part. So in ultrasonic testing, the inspector will use a probe or other type of transducer to transmit sound wave through the material being inspected. As we can see in the picture above, the inspector are using probe, which is the one that is located at the surface of the material. The probe then will produce a wave that are going into the materials. Okay, so the piezoelectric transducer is paired to a defect detector, which is the most fundamental form is the pulsar receiver. and oscilloscope display. So the oscilloscope is the one that the inspector are looking at. Now at the oscilloscope, the defect will be shown in the form of graph. So the transducer is moved around the inspected object or the inspected surface, which is commonly attached to the test sample by a gel, oil or water. The gel is help the probe to move smoothly around the surface of the material being inspected. Okay, the wave are then reflected and sent to the transducer when they hit a corrosion or a defect in the wall of the material. So as we can see on the picture, on the schematic figures beside, we can saw the probe, which is the one that is in red color, producing a wave. Then when it through a defect, the graph will be shorter. Okay, as we can see in the picture, which is at the right side, the graph is parallel. Then when it found a defect, the graph will be shorter. Okay, now we are going to salt spray testing. Okay, salt spray testing are the commonly type of testing that used for corrosion detection. So it is used because salt spray testing is low cost, well standardized and reasonably repeatable procedure. So the purpose of salt spray testing is to assess how corrosion will damage a specimen. So this testing allows us to examine the differing level of corrosion resistance exhibited by various metal and surface. Typically, salt spray testing is conducted in line with ASTM B117 testing step. So as we can see in the pictures below, this is the type of chamber that are used in the salt spray testing, which is the specimen being tested will be placed in the chamber. Then the spray nozzle will spray the solution of salt. Okay, next we are going to the salt spray procedure. Okay, first of all, the most important thing, we need to clean the surface of material that are being inspected. Then the sample are placed in the chamber according to the standard, and the test chamber's temperature are set based on the test standard. Okay, then make sure there is no sample is hiding other sample, which is that can cause the droplet from one sample to fall on another sample. So then we need to insert clean empty salt spray collection vessel around the sample inside the chamber, that is preferably at the height of the sample and never below the sample, because it can sink into them from above. Okay, next we need to check that the room temperature is within the acceptable limit, the temperature of the air saturator and the atomizer air pressure is within the acceptable limit. And next we need to spray to ensure that the spray continuously with atomizing saline solution at a constant chamber temperature of 35 degrees Celsius, and monitor the level of saline in the tank and make sure there is enough for the next 20 hours or the period that is used to inspect the material. Then after finish the salt spray procedure in the chamber, we can take a picture, then inspect type of corrosion that are happen at the material. Okay, now for the last part, we are going to the salt spray test period. So basically this test can last from 8 to 3,000 hours or longer in exceptional case, and use the 5% of sodium chloride solution with a pH range from 6.5 to 7.2. So basically, when we are using the material with black oxide coating, the sample exhibit corrosion 24 hours to 96 hours after. Then for the rust coating, even after 10,000 hours, the material still do not show any sign of red rust. Then for the powder coating, before the corrosion is observed, the sample basically lasts about up to 500 hours. Then for the HVACR coating, which is basically used in the marine industry, in the sea environment, the test basically consists of 25 cycle of varied condition lasting 1 week each, which is 72 hours of exposure to the sun, then 72 hours of exposure to salt spray, 20 to 24 hours of freezing, and after 25 weeks, which is 4,200 hours, the corrosion resistance of the test panel then is evaluated. So that's all for salt spray test.
So I want to present about type of corrosion, galvanic corrosion with label. So first, galvanic corrosion is sometimes can be occur under several environmental condition in aluminium alloy that can be triggered when it come into contact with steel fastener. So there is two dissimilar metal like electrode with a potential difference between them come into contact with one another in an electrolytic environment. Galvanic corrosion will occur. So the next, galvanic corrosion is an electrochemical deterioration of metal that happens. So galvanic corrosion have three conditions. So that condition must be satisfied before it can take place, the metal involved. So first, they must be electrically in contact, electrical ion that can be transferred to each other. And then next, they must located in an electrolytic environment. So they must be satisfy the environment for the electrolytic. And then the last one is they must have a significant distance between them in galvanic series. So there must be certain gap between two metal for the galvanic corrosion. So like you can see in the picture, there is sample of the galvanic corrosion. If you can see, there is no gap between two metal. There is aluminium alloy plate, and then the nut is stainless steel fastener. So this type of corrosion satisfy three of the main point for the galvanic corrosion to occur. So if you can see, there is corrosive production deposition under the plate between the nut and the aluminium alloy plate. So this can be galvanic corrosion to the aluminium alloy plate. Okay, next is character of corrosion. So character of corrosion have three types. So that I can present for you. Firstly is effect of solution. So the amount of galvanic corrosion that occurs is also dependent on the composition of solution. So solution of the corrosion that must be dependent for the composition of the metal. Although galvanic action protect the steel in all solution, the amount of zinc corrosion that occurs is dependent on specific composition of the solution. So this means two type of the metal must have specific composition. So when there is different composition, so the galvanic corrosion will be occur. And then when the conductivity is high, such as seawater, galvanic corrosion of the anomalic metal split evenly across the surface. So when the seawater contact to the metal, so the action, the ionic for the corrosion will be occur so fast because of seawater they have natrium chloride. So that thing will make the galvanic corrosion to be faster. Okay, if you can see, this is the type of effect of solution, conductivity, distribution, galvanic corrosion. If you can see, the picture A is low conductivity and B is high conductivity. You can see the original surface and after corrosion in tap water. So low conductivity will be expand to the surface. And then if you can see for the picture of B, high conductivity, you can see the original surface and the after corrosion in seawater. If you can see, there is no corrosion for the metal that is occur so fast. So if you can see in the A, in the picture of A, the corrosion will be expand to the outside original surface. Okay, next is as for atmospheric environment. So when the different combination of material are used in construction, building or structure that is exposed to environment atmosphere, this mostly happen because in the air of that we use must and also have water, H2O. So this combination of element will make the metal more to corrosion because of water they have ionic combination will be made the metal to react with each other. And then the measurement of weight loss in metal is also most commonly used when assessing galvanic corrosion in atmospheric environment. So this statement means when metal have a specific weight, so when in certain time or maybe in a long time, there must be quality control to different in the weight loss. So maybe let's say we have 80 gram 80 gram of the metal, and then in next 2 years we will check again, and then we will see how much the loss of weight for the original weight that we use 40 gram for the metal. So maybe it can be lost 5 gram or maybe 10 gram. Maybe the last weight that we can get is 70 gram of the metal. That is not corrosive yet. Okay, the last one is natural water. So like I say in 8.2 that our atmospheric environment have like gas. So in the gas we use air that we use have H2O that have water vapor. So this natural water in the certain condition like seawater, fresh water. So sometimes this type of natural water have conductivity. So in the seawater, in the salt in the seawater, there is conductivity is much higher than the fresh water because typically fresh water has lower conductivity to metal to react with the metal that make the corrosion. So the corrosion and anodic metal such as zinc or steel increased by factor 5 to 12 in seawater, and in the fresh water is only 2 into 5 factor. So we can see the conductivity in the seawater is higher than the fresh water. And then the next is a factor of 6 to 7 times more corrosion was observed. The chain of strike plate is same bimetallic. So if you can see 6 or to 7 times corrosion will happen in the same plate bimetallic. So when the same plate that we use to each other, there is 6 to 7 times between the different type of metal that we use in the galvanic corrosion that we can observe. Okay, that's all.
Okay, next part is galvanic corrosion prevention. So this part I will explain 6 way to avoid galvanic corrosion. First is insulation. Second is electrode isolation, selection of appropriate contacting metal, corrosion inhibitor, minimize the area ratio, and the last one is initial physical contact. First is insulation. Placing a non-conducting material between the contact points of the coupling metal is one of the most effective technique of breaking the electric channel in the electrochemical cell. Galvanic corrosion occurs when electron travel from the anode and to the cathode, resulting the galvanic current in the system. Insulation material prevent electron flow, hence inhibition, oxidation, and reduction reaction. So in practice, insulation is typically achieved by using polymer and elastomer based bushing, washer, gasket, and coating. For example, you can see the figure. Okay, second is electrode isolation. An electrode which is include ion that see the oxidation and reduction reaction in galvanic cell is one of the primary ingredient required for galvanic corrosion to occur. Method involving the isolation of the interacting metal and the electrode may be beneficial and preventing galvanic corrosion. So water replacement chemical that function as barrier between the metal substrate and the electrode solution are used to accomplish this. So paint, for example, is paint, coating, oil and grease have all be utilized such as force in a varieties of sector. So 3 is selection of appropriate contacting metal. Galvanic corrosion can also be avoided by minimize the potential difference between the metal. Previously state electron move from the anode to the cathode as a result of the potential difference, which function and driving force. The greater the potential difference, the stronger the induced galvanic current and the faster the corrosion. The opposite is true for metal, which is a small potential difference. Corrosion inhibitor are chemical in bracket are typically liquids, so applied to electrode to impede the chemical reaction that induce galvanic corrosion. Inhibitor act in a variety of way, the majority of which is involve complex chemical process. However, the most effective galvanic corrosion inhibitor are those that remove dissolved oxygen from the electrode solution. By removing oxygen, the chance of reduction occurring the anode is reduced. So the galvanic process is paused because cathode reaction depend on the anode reaction. Next is minimize the area ratio. Several studies have found that cathode area and anode that the ratio influence the pace and severity of galvanic corrosion. The greater than cathode area in respect to the anode. Example is the greater than anode to the cathode to anode ratio. The faster the reduction of at the anode, and hence to more severe the subsequent of galvanic corrosion. The smaller than the cathode to anode area, one of the hand, the less and damage the resulting degradation. So it is why to ensure the region of the more anode metal is largest as feasible in respect to cathode during the primary design state. So still fastener in the aluminium plate, for example, will be outperform aluminium fastener in the stay plate. So the last one is initial physical contact. So for this galvanic corrosion can sometimes occur without initial physical contact. So corrosion of a metal may result in a water soluble corrosion product, which is can deposit on the surface of another metal. So a good way to prevent incident like this from occurring is to ensure that the right material are used. Also keep in mind in the relative placement of a particular metal of a building. For example, one should ensure the guarded from a copper roof should be always be copper or stainless steel, but not aluminium. So for the conclusion is galvanic corrosion resulting force from a metal contacting another conducting material in a corrosive medium is one of the most common type of corrosion. It may be found at the junction of a water main where a copper pipe meet a steel pipe, or in the microelectronic device where different metal and semiconductor are placed together, or in a metal composite material which is reinforcing a material. So galvanic corrosion may result in quick deterioration of the metal, but in other case, the galvanic corrosion of one metal may result in corrosion protection of an attached metal, which is the basic cathode protecting by sacrifice anode. Understanding the mechanism of involved in this electrochemical reaction is key to selection to appropriate the most effective prevention measure for a given situation. That's all for me. Thank you.